the distance of a point 3, 8 and 2 from a line x minus 1 by 2 equal to y minus 3 by 4 equal to z minus 2 by 3 is required, but there is a condition on the measurement. How is the distance measured? The distance is measured parallel to a plane 3x plus 2y minus 2z plus 15 equal to 0. If you analyze the data from a point P whose coordinates are given 3, 8 and 2, we need the distance to a line. The line equation is also given x minus 1 by 2 equal to y minus 3 by 4 equal to z minus 2 by 3. But this is not the perpendicular distance that we are required to find. What is the distance required? The distance must be measured parallel to a given plane. That means when there is a plane whose equation is pi, that is 3x plus 2y minus 2z plus 15 equal to 0. Now the distance to the line is measured parallel to that of the plane. Then we need this distance of the point of intersection of P with the line which is parallel to the plane is Q. Then we need to find the distance PQ. Now as a plane equation is given to us 3x plus 2y minus 2z plus 15 equal to 0. One immediate identification about the plane is the normal to the plane. For this normal, what are the direction ratios? Yes, the direction ratios are 3, 2 and minus 2. So we know the normals drs of the given plane. Now can you tell me how will be the line equation which is passing through P? The equation of line which is passing through the given point P3, 8, 2 and parallel to the plane pi will be in the form x minus 3 by a equal to y minus 8 by b equal to z minus 2 by c. Then the lines drs are identified to be a, b and c. This line which is parallel to the plane. If this line is parallel to the plane, shall we say this line should be perpendicular to the normal? Let's call this equation as 1. Then an important observation is this 1 should be perpendicular to the normal of the plane. Now when do we say this line is perpendicular to the normal of the plane? Yes, a times 3 plus b times 2 plus c times minus 2 should be 0, or gives us a relation in terms of ABC 3a plus 2b minus 2c equal to 0. This is an equation in terms of ABC. Now as we need the proportional values to determine the direction ratios of the line, we need one more equation on ABC to get the proportionate values of ABC. Now the line PQ is intersecting the given line L. Now when do we say the line PQ is intersecting the line L? As the line PQ is intersecting the given line L, this is only possible if a point on the given line, if you observe, is 1, 3, 2. Now if these two lines are intersecting, then 3 minus 1, 8 minus 3, 2 minus 1, and with the drs of the line A, B and C and the drs of the given line L, which is 2, 4 and 3, this determinant must be always 0. Then only these two lines will be coplanar. We are using the condition for coplanarity of two given lines. Now when we expand this determinant, we get another condition on ABC, which is 15 times A minus 6 times B minus 2C equal to 0. Let's treat this as an equation 3. Now 2 and 3 are two simultaneous equations in terms of A, B and C. So can we solve them to get the values of proportionate values of ABC? So from the conditions 2 and 3, by cross product rule we get A by 2 equal to B by 3 is C by 6. So once we have the proportionate values of ABC, can we complete the line equation of 1 which is passing through P and parallel to the given plane? Therefore, from that equation 1, equation of the line through P parallel to the plane pi will be in the form x minus 3 by 2 equal to y minus 8 by 3 equal to z minus 2 by 6. Let's treat each of them to be proportional to t. Then the point Q on this line would be in the form 2t plus 3, 3t plus 8 and 6t plus 2. But where is this point Q? Not only on the line which is passing through P and parallel to the plane, this point Q is also on the given line L. As Q is also on the line L given by x minus 1 by 2 equal to y minus 3 by 4 equal to z minus 1 by 3. When is this possible? This point should satisfy this line equation. That is only possible if 2t plus 3 minus 1 by 2 is equal to 3t plus 8 minus 3 by 4 is equal to 6t plus 2 minus 1 by 3. Let's take any two of them. Then we get 4t plus 4 is equal to 3t plus 5, or this would in turn give t value as 1. Now once we have t value, can we identify the coordinates of q? Therefore q, which was taken to be 2t plus 3, 3t plus 8 and 6t plus 2, the coordinates for this value of t becomes 2 into 1 plus 3, that is 5, 3 into 1 plus 8, that is 11, and 6 into 1 plus 2, that is 8. So we got the coordinates of q. What is required now? Yes, we need the distance PQ, which is a distance measured parallel to the plane from P to the line. Therefore, distance PQ which is required is the distance between the points 5, 11 and 8 and the point P, which is having coordinates 3, 8 and 2. So that would be 5 minus 3 whole square plus 11 minus 8 whole square plus 8 minus 2 whole square, or which is square root of 4 plus 9 plus 36, or simply 7 units. So what is the distance of the point P from the given line which is measured parallel to the given plane? It is 7 units, which is suitably present at option D with us